Now that we've looked at a number of different coverage metrics, I'd like to return to a topic that I discussed at the beginning of this unit, which is the input domain. What coverage is letting us do is divide up the input domain into regions in such a way, for any given region, any test input within that region will accomplish some specific coverage task. Any input that we select within this particular region of the input domain will cause a particular statement or line to execute, cause a branch to execute in some specific direction, execute a loop 0 times, 1 time or more, etc. And so the obvious problem is, if we partition the input domain this way, and we go ahead and test it using a point from each region in the input domain, we're going to get good coverage. What we're not going to be able to do is find errors of omission. That is to say, nothing about this process of selecting points in the input domain and testing them in order to achieve good coverage is going to let us discover what we haven't implemented. And so let me give a quick example. So typically, as we talked about in Unit 2, the software under test is using APIs provided by the system. Perhaps the system under test is creating files on the hard disk. One extremely plausible kind of bug that we would put into the system under test is failing to check error codes that could be returned from file creation operations that happen when the disk is full or when there's a hard disk failure or something like that. And so what I really mean here is that, for example, we've gotten full branch coverage of the system under test, but there just isn't a branch in the test that should have been taken when the hard disk returns an error code. And so if the branch that should be there isn't there, when the disk does return an error code, something weird's going to happen. The software is going to fail. And so the fundamental fact here is that coverage metrics are not particularly good at discovering errors of omission, like missing error checks. To discover those, we need to use other methods. So for example, we discuss fault injection, where we make the disk fail, where we make it send something bad up to the system, and we see what happens. And in that case, if we're missing an error check, then the system should actually do the wrong thing, and we'll be able to discover this by watching the system misbehave. Another thing we could have done is partition the input domain in a different way. That is to say, not partition the input domain using an automated coverage metric, but rather partition the input domain using the specification. So if we partition the input domain based on the specification, and the specification mentions the need for our system to respond gracefully to disk errors, then there's going to be some little corner of the input space that's triggered only when disks fail, and we'll actually test that. So the point that I'm getting to here is there are multiple ways of partitioning the input domain for purposes of testing. Partitioning the input domain based on features of the code is one way, and it happens to be quite effective in general. But since it can't find errors of omission, we also want to sample the input domain in different ways. We also want to sample the input domain in other ways, and that's a theme that we'll return to in full force in Units 4, 5, and 6. All right, so that wraps up our quick survey of test coverage metrics.